In this video lesson, we're going to take a look, metaphorically, at how we look, literally. But first, let me introduce you to Tim Hughes. In an interview with ABC, he talked about what it's like to live with a condition called prosopagnosia. It started in primary school when he started to realize that he couldn't tell similar-looking people apart, even though others could. He tells the story of how he once went to his girlfriend's house to pick her up, and after a while of chatting to this woman, she said, I think you want my sister. He says that there was this other time that he lost his son Stuart at the beach, and he asked one of Stuart's friends where he was, and the boy looked at him and said, I am Stuart. What's going on? Well, believe it or not, Tim actually has perfectly fine vision. His brain receives the exact same visual input that we do, but something's gone wrong in the interpretation, specifically of faces. Prosopagnosia is also sometimes called face blindness. You see, seeing or sensing the image is only half of the process. How we perceive that information, however, is in some ways even more important. So let's go through these last three steps of our visual system, starting with selection. Our eyes have done the job of collecting and passing on the information to the brain, but now it's time to filter through and start making sense of what we're looking at. Starting with selection. It's impossible to process all the stimuli that enters the eye at once, and so our eye and brain have been designed to be selective about what we give our attention to. We've got these things called feature detectors, which are specialized cells in both the optic nerve and the primary visual cortex. Feature detectors are sort of these centers that only activate in response to specific features. For example, a line at a certain length or angle, or if it was moving in a certain direction. This is thought to help our brain extract relevant cues and just ignore the background noise. Now that might sound a bit complicated, but here's an example. Hewitt did this kind of cute study on toads in 1970, where he found that if you took this black bar and if you moved it sideways, like horizontally, it sort of evoked interest in the toads. Whereas if you moved it up and down vertically, it sort of resulted in like avoidant behaviors. Now, clearly these black bars shouldn't really mean anything to these toads because they're not things that they see normally in nature. But he concluded that toads must have detectors for these specific features because something of roughly the shape, moving left or right, could be an insect or prey that it might want to eat. Whereas if that shape was moving up and down, it's more likely to be a predator and something that it should run away from. So even though all he was moving were shapes, it could be that the toad's visual system was detecting these features and telling the toad something else. The next step is organization. We are now in the visual cortex of the brain, where it starts to see if it can recognize or like quickly make sense of anything it sees. This is done using some principles, such as perceptual constancies, Gestalt principles, and depth cues, but these are all things that we're going to be looking at in much more detail in future lessons. And once the image is reassembled using these principles, it then gets sent to both the temporal and parietal lobes. Why? Well, the temporal lobe is important in interpreting and identifying the object, and that is why shape and color perception is sent that way. However, motion and direction is directed to the parietal lobe, and that's because that's where positional information and also motion is analyzed. And all this makes up the final step that we call interpretation, which is where visual stimulus is made sense of, is given meaning. As mentioned before, the parietal lobe is what helps us judge our position and motion. And so if this part of the brain is damaged, the patient might constantly bump into furniture or misjudge picking up their cutlery. The temporal lobe is the one that interprets and identifies objects. And so if this part of the brain is damaged, the patient might be unable to recognize an object or a familiar face. Remember Tim Hughes from the start of this lesson. And there you have it. Through those 6 complex steps that happen like instantly, you are able to see, and sometimes see very strange things indeed. Oh, before we end, I should quickly mention that everything that you're able to see really only comprises a very small spectrum of a really wide, large spectrum that we call the electromagnetic spectrum. This teeny section that we can see is what we call visible, and everything else is invisible, but really in essence the same type of energy, just different in some of the physical attributes. So on one hand, it's incredible that we've got these organs that can detect this type of energy, but on the other hand, there is so much that our eyes do not see. Alright, that's it from me. See you in the next lesson.